Alright, hello class. Today we're going to be looking at lesson 27, which is on linear systems in two variables. So to start with, what is a system? Well, a system of equations is when you solve more than one equation all at once, right, simultaneously. So I think the quickest way to talk about it is with an example. So let me just start with an example of what a system of equation is, and or system of equations is, and we'll start talking about methods on how to solve these and what they sort of mean for us in terms of applications and geometrically. Okay, here's an example. We have 4x plus 3y is equal to x minus 4y. Okay, so we want to solve for x and y simultaneously. So we're solving going to solve for x and y simultaneously. Right, and our solutions are going to be ordered pairs. All right, so solutions to this will be of the form, say, points x comma y. Okay, so the first technique we have for solving these, okay, so solving systems, there are a couple of techniques. We're going to basically look at two. Okay, and the first is with a method called the substitution method. Now, I'm fairly certain that these kind of problems you all have seen before in some sort of way or another, where you have, say, two equations that you're dealing with, and what you do is you solve one equation for one of the variables and then plug what you have into the other one. That's what the substitution method ends up being, is you solve one equation for a variable, so for one variable, okay, then plug what you have into the other equation. So plug what you have into the other. Okay, so like I said before, you've likely seen this before, just in, usually it's in word problem type things or application problems, but what we're going to do is we have these two equations here. I'm going to solve this second one for x. Okay, so we're going to start with this x minus 4y, and we're going to start with this one. We can start with any of them, it really doesn't matter. We can solve for any variable, but I usually choose the one that would be the simplest. So here we're going to take the second equation, which is x minus 4y equals 0, and I'm going to solve it for x. Okay, which is basically just moving that 4y over. All right, so I'll add the 4y to both sides. Okay, and get that x is equal to 4y. Okay, then we're going to plug this in into the first equation, so the other equation. So we start with the second equation. Now we're going to go back to the first equation. So let me write out the first equation. And if you don't remember, we'll go back up to look at it. It's this 4x plus 3y equals 0. So 4x plus 3y equals 0. And what I'm going to do is if I have that x is equal to 4y, I'm going to replace x here with the 4y. Because then what happens is I get this entire equation in terms of just y. Okay? So that's what I've done. I've taken this x expression and then plugged it in to the other equation. So that's how this works. We typically just solve one of the equations, whichever one you want, really. It's not going to matter. The work might be a little more complicated in each step. There's probably a more efficient way to go in each problem, but not a necessarily right way to go. Okay, so what you do is you solve one of your equations for one of the variables, like x equals something in terms of y equals something in terms of x, and then you plug it into the other piece here. Okay, and then after we do that, we're just going to simplify and see if we can solve. So 12y plus 3y is equal to 0. We'll combine our like terms and get that 15y is equal to 0. Dividing both sides by 15, we get that y is equal to 0. Okay, so there is my y. Now that is one piece of the solution. I need the other piece. So if y is equal to 0, now we're going to plug this back into what we had here. Or plug it into any of our equations, actually. We could plug it back into here, too. I could plug that 0 in and get that 4x is equal to 0, or I plug it all the way back into here and get x is equal to 4 times 0. However you do it, wherever you plug this y in, you're going to get the value for x. Okay, so I will plug it into this expression here since it's already solved for x. Right, if x is equal to 4y, plugging 0 in gives me x is equal to 4 times 0, so x is equal to 0. Okay, so from here, when you write your solution, we'll say the solution set, we do that whole thing again. The solution set is, and we put it in brackets, but it's the point 0, 0. Okay, and let me show you why this is a point. Okay, I'll use this example to do that. Okay, if we go back to our original thing, our 4x plus 3y is equal to 0, our x minus 4y is equal to 0. If we solve both of these for y, okay, let's see what we get. So what I'm going to do is on a different sheet, I'll rewrite this equation, and we'll start to solve both of these for y. Okay, here's the equations again. And we're going to solve both for y. This is not usually how we do this, but I just want to show what's going on. So we're going to solve both for y. So on both cases, I'll move the x's over. So in this case, I'll get that 3y is equal to negative 4x. In this case, I'll get that negative 4y is equal to negative x. Okay. Then we'll divide both sides by the whatever it is we get. So in this case, I'll divide by 3 to get y is equal to negative 4/3 x. And here, I'll divide by that negative 4 to get y is equal to 1/4 x. Okay? Now here's what's going on with these. These are linear equations. And that, of course, was in the name, linear systems, right? It's in the name of the lesson. But specifically, these are lines. Okay? And what that means is if I say graph these lines, so the first one, has a slope -4/3 and y-intercept 0. So this is our slope and our b is 0. Okay, so I have y-intercept is 0, so it goes through the origin, and it has a negative slope. Okay, so if we do our rise over run as it goes out 3, and let me try and make that even there. As it goes out 3, it goes down 4. 1, 2, 3, 4. Okay, so that's what our first equation looks like. All right, so here's equation 1. Or my y equals -4/3 x. Okay, my second equation, it has a positive slope. Its slope is 1/4, so as it goes out 4, it goes up 1, and it also has a y-intercept of 0. Okay, so it will go out 4, up 1. So this line looks something like this. I didn't graph that very well. But here's equation 2, which is y equals 1/4 x. Okay. Now, where do these two lines intersect? They intersect here at the point 0, 0. So when you solve a system of equations, what you're actually finding is the place where they intersect. Okay? So we found that was actually our solution set here. When we got down to the end, our solution set was actually 0, 0. And we found when we graphed these lines here, we got the intersection point 0, 0. Okay? All right, let's look at another example. Okay? So here's another example, a little more complicated. We got rid of our zeros. And we're going to tackle this the same way. So with our 7x plus 8y is equal to -19, and our 5x minus y is equal to 20. Remember, we're always going to solve one equation in terms of the other variable, then plug it in. So I'm going to call this equation 1 and equation 2. Okay. Now, in general, what I always do is I look at both equations and see which one might be the easiest to deal with, which one might be the nicest to solve for. And my eye naturally goes to equation 2, and solving for y would probably be the easiest thing to do. So I'm going to solve equation 2 for y. Notice what I did here. I'm actually writing a little statement telling me what I'm about to do. And that's for a couple reasons. One, if I go back, I know exactly what I've done, what my thought process was. Also, it just gives me a guidepost. It gives me purpose, right? So I'm actually not just thinking about what I'm doing, I'm being very deliberate about what I'm doing. Okay? So, and notice here, you don't have to do this like I am. If you just always do this by solving equation 1 for x and then plugging that into equation 2 and solving that, you'll always still get the right answer, provided you do everything correctly. But I always like to see what would be the simplest way to go. All right, so I think solving for y in equation 2 is probably the best way to go. So to do that, I'll move the 5x over, so I'll get -y is equal to 20 minus 5x. And then with this -y, I'll just divide everything by -1, or just change the signs of everything. So I have y is equal to -20 plus 5x. Okay? And this, I'm going to take this thing here and plug this into equation 1, the other equation. Okay, so equation 1 was up here. that's our 7x plus 8y equals negative 19. Notice I've solved for y, so I'm going to take this thing and put it in for y. Okay, so I'm just going to, and I usually write it out completely. I have 7x plus 8 times now negative 20 plus 5x is equal to negative 19. Okay, so now we'll distribute that 8 and move towards solving for x, which then will again let us get y. Okay, so 8 times 20 is going to, of course, and that's a negative, so I have 7x minus 160, okay, then plus 40x is equal to negative 19. So I'm going to combine like terms here to give me 47x, and then I'm going to move that 160 over. It doesn't seem how far we get in math. I'll still see this common issue here. Make sure you add 160 on both sides. Okay. So what we end up with here is 47x is then equal to 141. So x will then be 141 divided by 47, which ends up being 3. So x is equal to 3. Okay. Now we're going to take this and plug it back into this formula. Now you could plug it back into anything. You could plug that 3 back into here, but we'd have another equation to solve. You could plug it back into here, but again, we'd have another equation to solve. It's usually easier to just plug it right back into the one that's already solved. So we're going to plug it back into our solved equation 2. Right, which was y is equal to negative 20 plus 5x. So I'm going to plug that 3 in and get that y is equal to negative 20 plus 5 times 3. Okay, so what we end up with is negative 20 plus 15, or negative 5. Okay, so the solution set brackets, I'm going to put the 0.3, negative 5. Be careful with that. Make sure you match your x and your y. Remember, our x was 3, our y was negative 5, so when you put that point in, just make sure you've got it, got everything in the right places. Alright, let's do another example of substitution method before we talk about what the next method is. So, in this case, things are a little more complicated. It's not as cut and dry as the others are, but we're still going to solve one of our equations and then plug what we have into the other one. So, this one's tricky. And as I've said before, no matter how you do these, you should still get the right answer out, but in every case, there's typically a best practice way to go about it. Okay, so in this case, it may look like equation 1 is the way to go, but actually I'm going to solve equation 2, and you might think it's weird that I'm always picking equation 2. It's not always the case that equation 2 is the better one, but I just want to show that in this case equation 2 will probably be best if we solve for y. And here's why. When I start moving things around, you notice if I move the 8y over, I get 9y minus 8y, which is just y. So I get y equals, and if I move the x stuff over here, I will just get y equals some stuff. Okay. If I solve stuff over here for y in equation 1, I'm going to get some nasty fractions showing up. Okay. And we don't really want that. So doing it this way is going to help us avoid fractions. Okay. So, which again isn't the worst thing in the world, but if we can avoid it, we're going to try to. Okay, so I'm going to solve for y. So I'm going to move the 8y over to get 7y. Oh, not 7y, sorry. 9y minus 8y is 1y. Is going to be equal to, now the x minus 9y will be a negative 8x plus 76. Okay, so we have now solved equation 2 for y. And we didn't have to divide by anything, so I actually try to avoid dividing by stuff if I can. Sometimes you can't, but you know, in this case, thankfully we could. Alright, so now we're going to plug this into equation 1, if you can read that. Okay, we're going to plug this into equation 1. And actually, equation 1, I'm going to simplify a little bit. Okay, I'm going to move that negative 3x over so that I have 9x here. Okay, so equation 1 is 6x minus 5y is equal to 61 minus 3x. And I'm going to move that 3x over, so I have 9x minus 5y is equal to 61. And you can do this for, you know, all your equations before you start doing stuff. And then we will plug this y in to our y. Okay. So I'm going to get 9x minus 5 times negative 8x plus 76 is equal to 61. And now we have an equation to solve just an x. And that's what you should always have. Once you plug one into the other, you should always have a nice equation in x, or y, just a single variable. So I'm going to distribute this 5, negative 5 I should say. So I have 9x plus, this will be 40x. Okay, and then 5 times 76 ends up being 380. Don't forget the minus sign, and that's going to be equal to 61. Okay, so I'm going to move some stuff over. I'll move that 380 over, and I'll combine these, so I'll get 49x is equal to 441. Okay. So dividing both sides by 49, I get that x is equal to 9. Alright, quite a long walk, but we got there. Now I'm going to take that x and plug it back into an x somewhere, and it really doesn't matter where that somewhere is, but I'll plug it into this expression we got earlier, that y is equal to negative 8x plus 76. Okay, so we'll get y is equal to negative 8 times 9 plus 76, so y is equal to negative 72 plus 76, so we got 4. Okay, so the solution set here, back to what our equation was, the solution set is x was 9 and y was 4. Alright, and there we go. That is the substitution method. Now let me talk about what is called the addition method. Okay, so the second technique And there are many, many more techniques for, solving these things, but we're only really going to look at two. The second technique is the addition method. Okay, and the thing about this is, yes, you could solve everything with a substitution method, but it's actually the longest way to go about it sometimes. And what's interesting about the addition method is it shows us that we can actually manipulate our equations like we do anything else. Okay, so we can add, subtract, multiply, divide our equations like we would just numbers or anything else. So we can actually kind of approach this like we would say some other sort of equation. So what I'm going to do is, with this setup here, the system, I have x plus y is equal to 1 as my first equation, and my second equation is x minus y plus 7. And what we're going to do to solve this, so to solve using the addition method, and this might be a misnomer because we could use subtraction too, but I'm going to add equation 1 to equation 2. Right. Well, how do I do that? Well, I'm going to take this x plus 1, this x plus y is equal to 1, and then I'm going to add x minus y is equal to 7, and I'm just going to add this like we normally would. Okay, so I'm taking equation 1 and I'm adding equation 2. Alright, so x plus x is 2x. Y plus a negative y is 0y. So I'm going to write that as 0y here, is equal to 1 plus 7. So that's 8. Okay, so I get that 2x is equal to 8. If I divide by 2, I get x is equal to 4. Alright, and so now we can, from here, find our y, either doing the same thing or just plugging it in and simplifying from there. So one thing we can do now, I just want to show, we could plug our 4 into our x and solve, okay, but what I want to do maybe instead is let me subtract equation 1 and equation 2. So now let's subtract equation 1 from equation 2. Okay, so equation 1, so we're actually subtracting equation 1 from equation 2. So I'll take equation 2, so here's 2, x minus y is equal to 7, and then I'll take equation 1 and I'm going to subtract it. So that means I'm going to change the sign of everything. Right, so I have x minus y is equal to 7, and then if I change the sign of everything, I'll have negative x minus y is equal to negative 1. So here's 2, and here's negative 1. Right, and then we'll add these two. So what I'm essentially doing is, instead of really subtracting, I'm adding the negative equation. Okay? And in this case, the x minus x becomes 0. The minus y becomes negative 2y. And 7 minus 1 becomes 6. So I have negative 2y is equal to 6, so y is equal to negative 3 when I divide. Okay, so the solution set is 4, negative 3. Now, this is, I know, a little abstract, but let me show you what happens if we compare this to the substitution method. Okay, so with the substitution method, I get this. So if I solved equation 2 for x, I get x is equal to 7 plus y. And I could plug that back into equation 1 for my x and get that 7 plus y is equal to 1. So combining my like terms, I get 2y, and I move that over, I get 2y is equal to negative 6. So y is equal to negative 3. Okay, plugging negative 3 in here, I plug that back into here, I would get that x is equal to 7 minus 3, so x is equal to 4. Okay, so we ended up getting this same thing using the addition method. Now here's the thing. The addition method is kind of abstract, I get that. I know a lot of people don't like it when they first see it. And here's the thing. MyLabs Plus is going to tell you to use the addition method or the substitution method, but it doesn't really have a way to ensure that's actually the method you used. Okay? So if you don't like the addition method, you don't have to use it. But I do recommend trying it, okay, when it tells you to, because when you get used to it, it's actually a faster way of doing these problems than the substitution method. The substitution method is actually kind of slow, whereas the addition method is kind of fast if you know what you're doing. Right? So let's look at a couple more examples, and hopefully it starts to kind of settle in a little bit of what we're trying to do. What you're really looking for is things that will cancel. Okay? So let's see. Okay, so here's a system. 4x plus 8y is equal to 12, and 2x minus 8y is equal to 6. So when I look at this, my first thinking is actually to use the addition method. And the reason is, when I look at this, I see that the 8y's will cancel when I add this together, right? If I were to just add these two equations together, okay, I would get a new equation. I'd get 6x plus, now the 8y minus 8y would cancel out to be 0, and this 6 plus 12 would give me 18. Okay. So I'd now have a 6x is equal to 18. Divide both sides by 6, and you'd get x is equal to 3. Okay, and now you can either plug this 3 in, or you can use some more manipulations to solve this. Okay, so let me show what happens if we just plug in, if I wanted to plug in, right? So if I wanted to do half addition, half substitution, which is totally legit, right? It's totally legal to do that. Now, if I wanted to plug this in, let's plug it into equation 2. Okay, so I get equation 2 is 2x minus 8y is equal to 6. I'd plug 3 in, I'd get 2 times 3 minus, can't really see that, minus 8y is equal to 6. Okay, so you'd get 6 minus 8y is equal to 6, and the 6's are going to cancel. When I move the 6's over, I get negative 8y is equal to 0. so y is equal to 0. Okay, so doing it this way, this is half addition, half substitution. Okay, because we did the addition method to solve for first one variable, and then we plugged it into one of our equations to solve for the second variable. Okay? If I wanted to do full-on addition method, so I used an addition method to solve for the first variable. Now, so to solve for x, maybe I want to do that to solve for y. So if I have 4x plus 8y is equal to 12, so we're going back to our original problem. Then 2x minus 8y is equal to 6. Okay? So, what we would do here. Okay, so here's equation 1, equation 2. What I want the x's to cancel. Okay, so what I do is I pick the thing that would make them cancel. Right? So we're going to pick -2 and multiply equation 2 by it. Okay, so I'm going to leave equation 1 alone. Okay, and now I'm going to multiply equation 2 by -2. So that's going to make this -4x. That's going to make this plus 16y. It's going to make this a -12. Right? So this is equation 2 times -2. Right? Being a little sloppy with my notation there. But the reason is, now if I decide to add these together, the x's cancel. So I get 0. Okay? And then I have this 16y plus 8y, which is going to be 24. 24y, not just 24. And then I get 12 minus 12, which is equal to 0. So y is equal to 0. So we ended up getting the same y value either way. Now, I know for some of you, this method is going to look very abstract, and you'd rather just use the substitution method every single time. And you know what? I can totally understand that. But when you get comfortable with this, right, you can do these things much faster, and you can deal with fractions and things much faster doing it this way than substitution. Okay? That's really all there is to it. It's really the only point I'm trying to make with this. So, you know, in general, if you don't like the addition method, and again, I suggest you at least try it a few times when it tells you to, because usually if it tells you to, there was probably a good reason for that. Okay, usually. But again, you're not out in the wild. You aren't like restricted to anything, right? You can you could do half and half. You can mix and match, or you could just always use substitution. Okay, so here's an example. I'm going to do addition method again, just so we have 3 examples of both types, but using the addition method. Right, if this is equation 1, this is equation 2. Now this one, you might not naturally think to use the addition method, because neither of these things are going to just naturally cancel. Okay? So what we're going to do instead is I'm going to see if I can find a thing that I can multiply maybe equation 1 by to get it to match equation 2. So to cancel the x's, okay, let's multiply equation 1 by negative 2 again. It won't always be negative 2, but in this case, that's actually going to work. Negative 2 will get, so negative 2 times equation 1 is going to be negative 2x minus 8y is equal to positive 18 when you multiply all of equation 1 by negative 2. Okay. Then equation 2 is left alone. It will just be 2x plus 5y is equal to negative 12. Okay, so I'm going to add these together, and the negative 2x plus the 2x cancels to give me 0. The negative 8y plus 5 is going to give me a negative 3y. Okay. And then the 18 minus the 12 is going to give me 6. Okay, so here we go. Now y is going to be, when I divide by the negative 3, y is negative 2. Alright. Now in this particular example, I would actually do a half and a half. I would plug this y into, say, equation 1 and solve for x. Right? So that negative 2 would make that negative 8, and I would add that over. So in this case, I'd plug into equation 1 and get x is equal to 4 times negative 2, which is, oops, that's a plus, and equals, my bad, plus, so 4 times negative 2. So what we end up with is x minus 8 is equal to 9, negative 9 that is. I'm going to add 9 to both sides to get that x is equal to negative 1. Okay, so our solution set ends up being negative 1, negative 2. And that's how I would end up doing this one. But what would happen if, say, you wanted to say you wanted to use addition method for everything? Okay, so say you had x plus 4y is equal to negative 9, you had 2x plus 5y is equal to negative 12, and you wanted to use the addition method to cancel y. Okay, well, there's a few ways we can do this. We see we have a 4y and a 5y. There are two ways we can, I say two ways. One way is to introduce fractions. So we would do 1/4 the first equation to make that just a y, and maybe negative 1/5 the second equation to give us a negative y. The problem is that would introduce like fractions, which we may not like, situations like that. So what we do instead is we sort of cross match. Right? We're going to multiply equation 1 by 5 and equation 2 by negative 4. So we'll multiply equation 1 by 5 and equation 2 by negative 4. And it doesn't matter which one gets the negative, as long as just one of them gets the negative, things will cancel. Okay? So when we multiply equation 1 by 5, you'll get 5x plus 20y is equal to negative 45. Okay? So this is 5 times equation 1. Then negative 4 times equation 2. Okay, I'm going to take negative 4, multiply it by that 2x, so I'll get negative 8x. Okay, then minus, so the negative 4 times 5y will give me negative 20y, and see what happens here? Now these two things are going to cancel when we add everything together. So So that's what we're looking for. So basically, the addition method is find a thing that will make everything cancel. Okay? So, and then now the negative 12 times 4 will be a positive 48. Okay? So now when we add these together, add the 5 minus 8x, so I'll get negative 3x. I'll have the 20y minus 20y, that cancels, and I have negative 45 plus a 48, which is 3. So I get negative 3x is equal to 3, so x is equal to negative 1. And we got what we got before. Okay, so the whole point here again is that, you know, I'm not trying to restrict you, saying you have to use certain methods, but this addition method can actually be pretty helpful. And I'll show you a situation where that might even pop up, where you might want to, even if you don't use the addition method, you might want to multiply by things anyway. Alright, let's take this example. Say we have y minus 1/5 x is equal to 2/5, and y minus 3/4 x is equal to 7. Alright, in this case, we already want to get rid of our fractions by multiplying by something that will get rid of them. So we're already going to multiply, say, this equation by 5 and this equation by 4. Okay? And when we do that, since we're already doing that, in some cases, you know, this whole idea of multiplying everything by a number isn't all that new. It's not all that weird, because we're going to do that here, and we've been doing that for a while to actually get rid of fractions, because when we do that, we'll end up with 5y minus x is equal to 2. Okay, and in this case, we're going to get 4y minus 3x is equal to 28. Okay. And, you know, we're already multiplying things. So here, we could either then do substitution, we could do addition, we could do half and half. We could actually pick the right things here, since we're already multiplying, to get things to cancel in some nice way. I'm going to say multiply equation 1 by negative 3, because that's going to make this a positive 3, which will cause things to cancel nicely. Right, so I'll do that down here. I'll get negative 15y plus 3x is equal to negative 6. So this is our equation 1 now times negative 3. And then I'll have 4y minus 3x is equal to 28. Okay? So, from here, when I add these things together, the negative 15y plus 4y will become negative 11y. The 3x minus 3x will cancel, and then the negative 6 plus 28 will end up being 22, so y is equal to negative 2 when I divide both sides by 11. Okay. And then I'm actually, can't really see that, I'm actually going to do a half and half. So now I'm going to take this negative 2 and plug it into my equation 1 from up here. Okay, and you could pick really anything, but that's going to end up being, when I plug in the negative 2, I'll get negative 10 minus x is equal to 2. So I'll get negative x is equal to 12 when I move the 10 over. And so I get x is equal to negative 12. Okay, so the solution set is a negative 12, comma, negative 2. Whew. Okay, so that is the addition method and the substitution method. like I've said a couple of times now, you can utilize these whichever way makes most sense given the problem. And again, when it tells you to use a certain method, go ahead and try it, because that addition method, though it may seem a little off-putting right now, it actually is your quickest way. Because if I didn't waste my time, I shouldn't say waste my time, but if I didn't take all this time explaining all my steps here, actually that addition method is way, way faster than the substitution method in general. But again, it's not always about doing things the fastest way, it's about doing things the right way. So if substitution is how you are able to do it the right way, then by all means, do it that way. Okay, and that is about it for this particular topic. So in the next lesson we will look at what happens when we have three variables, or how we expand this a little further. We'll look closer into applications of how this works out. In your homework in this lesson, you will see some very basic applications involving cost and revenue. Okay, and you just keep in mind when you see those problems, you actually have the skills to put all that stuff together from what we've done here. Okay, you'll even see graphs in some places that will match the graphs that we saw early on. So remember, as we're doing this, there's a geometric component to it as well. That's why we get a point each time. We're actually finding the point where these lines intersect one another. Okay, so anyway, as always, if you have questions,